Hi, this is Brother Tony, and this lecture goes with learning activity number 3, which is analyzing evaluated trust. So we have 4 objectives right now. We're going to understand and use the Pythagorean Theorem, understand and use right-angle trigonometry to solve for angles. Now probably some of you have already had the Pythagorean Theorem and right-angle trigonometry, so this will be a review. That's fine. Number 3, know the parts of a vector. And 4, demonstrate how to break down vectors into components and then solve for a resultant vector. So let's begin. Okay, so the first thing, let's understand and use the Pythagorean Theorem. So many of you have seen it as this: a squared plus b squared equals c squared, which mathematically evaluates to c equals the square root of a squared plus b squared. But what this means is the two sides closest to the right triangle, to the right angle, b squared plus a squared equals the hypotenuse squared. So now let's do an example with this. Okay, so here we have a right triangle with the two sides closest to the right angle of 3 and 4. So let's write that as a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. So 9 plus 16 is 25. 25 equals c squared. Take the square root of both sides. C equals plus or minus 5. However, since we're doing this in engineering, the negative 5 means nothing here. So c, so the side of this hypotenuse is 5. Okay, let's try another one. So here we have the hypotenuse now is 10, and the longer side is 9. So how do we find the short side? Well, c squared equals a squared plus b squared. So 10 squared equals 9 squared plus b squared. 100 equals 81 plus b squared. B squared equals 19, because 100 minus 81 is 19. And if I take the square root of both sides, b equals plus or minus the square root of 19. But really, b equals the square root of 19. Does it matter that I named this side a and this side b this time? Absolutely not. It's arbitrary. The only thing that is not arbitrary is the hypotenuse is always c. Okay, the second objective is to understand and use right-angle trigonometry to solve for angles. So now let's just talk a little bit about what's underlying trigonometry. You have a right triangle, and that's all we're going to be using trigonometry for right now, is to solve problems with right triangles or right angles. Now we have theta. That circle with a line through it, that's a Greek letter for theta. We have theta 1 right here, and we have theta 2. And these two represent the angles. They represent the angles at either end. And you know the square is 90 degrees. A triangle has to add up to 180 degrees. So now, what we're saying is the sine of theta 1 is a ratio between the opposite and the hypotenuse. So the angle, sine of theta 1, will be a ratio of a over c. And that ratio, which will be always less than 1, that ratio can be converted into an angle. The sine of theta 2 is also opposite over hypotenuse. We have cosine of theta 1, adjacent over hypotenuse, cosine of theta 2, which is adjacent over hypotenuse, that's a over c. Now if you look at this, the cosine of the opposite angle is the same as the sine. So cosine of theta 2 is exactly the same thing as the sine of theta 1. Cosine of theta 1 is the same as saying the sine of theta 2. Now the third definition, tangent, is opposite over adjacent. So the tangent of theta 1 is a over b. The tangent of theta 2 is b over a. These are definitional terms. These are definitional terms that represent the ratios. So what I did here is I rewrote the trigonometric functions again, sine, cosine, and tangent. Now what we have here is we have theta 1 of an angle of 50 degrees, and by the way, theta 2 would then be 40 degrees because you know all angles, all triangles must add up to 180 degrees. Side B is 7. So the question I have is what would side C be? So here's how you use the trigonometric functions. You say, okay, we know we have an angle. We have a side and we have a hypotenuse, and the side happens to be adjacent to the angle that we know. So what would we use? Cosine theta. So we would write cosine 50 degrees equals 7 over C. Multiply both sides by C. Sorry about that, yeah. Multiply both sides by C, divides both sides by cosine of 50 degrees. C equals 7 divided by the cosine of 50 degrees. Put that into your calculator. C equals 10.89. Now, make sure for your calculators, most of the default for a graphing calculator is the degrees are in radians. Your angles are in radians. You need to change that to degrees. Good way to check it is put in sine of 30 degrees. Do sine 30, and if it's in degrees, you will get 0.5 because the ratio of opposite over hypotenuse is always 1 to 2. Okay, here's a problem for you to work on. What we have now is theta 1 is 50 degrees. We have side B of 7. We want to know what is the length of side A. Okay, so stop the tape right now, stop the video, and figure that out. Figure out what trigonometric function you're going to use, and then once you're ready, start the recording again. Okay, I hope you tried to solve that. So what do we need to do? Well, we know that we have theta 1. We know that we have one side, or the short side, but we need to find the other short side. The only trigonometric function that actually works is tangent of theta, because you have an angle, and you're using opposite over adjacent. So how do we do that? Well, let's start out. Tan of 50 degrees equals the opposite, which is A, over adjacent, which is 7. Well, let's multiply both sides by 7, so we do 7 times tangent of 50 degrees equals A. And we have A equals 8.34. Now, a word to the wise. We want to look for reasonableness. And is that reasonable? And I would say yes, because look, if you have an angle that's 50 degrees here, this angle on the other side would be 40 degrees and would open up slower on this side. So if your side B is 7, then your side A of 8.34, that makes sense. Now if you got something like 0.5 or 83.4, you know you've done something wrong. So keep that in mind. So the third thing we want to go over is knowing the parts of a vector. A vector has both magnitude and direction. Okay. The magnitude oftentimes is represented by the length of the vector itself. So the longer the length, the greater the magnitude. And then the direction is the arrow. So if we call this A, vectors are either in bold, which you see in your reading, or they have a little hat on that demonstrates they're a vector. Now here's the idea. We have a right triangle right here. When we do our analysis, we do not know how to mathematically add a vector that's not either on the x-axis or the y-axis. What we need to do is we need to break that vector down into its component, x part and y part. And then, as long as vectors are in the same direction or exactly the opposite direction, we can add them together. So let me give you a quick example. So we have our vector A. Here's what we do to break down the components in the x direction and the y direction. This vector A is represented by the force in the x direction as well as this force in the y direction. And the way you draw this triangle is you start at the tail of your resultant vector, and this is one vector right there going to the right. The second one, f of y, is going straight up, and it meets at the tip of the arrow. You notice these two, f of x and f of y, have both magnitude and direction. So here is a vector that I will label G, for no other reason than to give G a little bit of its due. Stop the tape right now, and I want you to draw the component vectors, f of x and f of y. If you did that successfully, you know that you started from the tail and you went down, so this is f of y, and then you went over there, and that's f of x. And if I was doing this very exactly, you'd see a very nice right triangle there. That's what we need to get to. Okay, time for an example. You have a vector with a force of 20 newtons. So the force, the direction of magnitude, so you have magnitude of 20 newtons, and then the direction is I'm going to give you 50 degrees. So right here, theta sub 1 equals 50 degrees. And I'm going to ask you to break that down into its component vectors. Okay, so I now have two component vectors. One is the force vector going in the x direction, and the second one is the force vector going in the y direction. Okay, so now let's get f of x and f of y. So we see for f of x that theta 1 is 50 degrees. So f of x is adjacent to theta 1. So the cosine of theta 1 is adjacent over hypotenuse. The cosine of 50 degrees equals what is so f of x over the force of the hypotenuse, which is 20 newtons. So f of x equals 20 times cosine of 50 degrees. F of x equals 12.9 newtons. Now, I want you to try and figure out what f of y is. So stop the video and try it right now. So sine of theta is opposite over hypotenuse. Why did I choose sine? Because theta 1 is opposite of this side, f of y. So sine of 50 degrees equals f of y over 20. Now to get f of y equals 20 times sine of 50 degrees. So f of y equals 15.3 newtons. Now as a test, if you square 12.9 newtons and add 15.3 squared, and then take the square root of both, you will get 20 newtons. Okay. A lot of stuff in here, so don't be afraid to go back, review it, have questions ready for class, and I'll see you in class and we'll do some more of these.